4.4, derivatives of exponential and logarithmic functions. Whoa. These are actually, honestly, pretty easy derivatives overall, I would say. So, number 2, these are just find dy dx. Y equals e to the 2x. All right, so no matter what e is raised to, the derivative of the first part is always e to the x, or like e to the 2x, whatever is in that exponent. So, y prime equals e to the 2x. Now, this is a chain rule. So this is like the e to the u that you had in your notes. So I need the derivative of 2x, which is, so we multiply it, and we get y prime is equal to 2 e to the 2x. So 4, y equals e to the negative 5x. What would this one be, you think?
1. Oh, wait. Are we putting it over 1 or under 1?
No, just leave it as is.
Okay.
Just like if you had x to the negative 2, like treat it like that, kind of.
Okay. Negative 5 e to the negative 5x.
Yep.
Okay.
Everyone always is like, this is too easy. Like, there's no way. This is too easy. I'm like, no, it really is that easy, though.
I mean, I'll take it.
Yeah.
Like, when you've done all the other stuff you've been doing and you get to this, you're like, oh. Like, yes, like, there's still chain rules and quotient rules and product rules and all of those things, but you always know e to the whatever is e to the whatever times the derivative of the whatever.
Pretty simple.
All right.
It just feels like it should be harder because it's e's.
Yeah. But e is just a number like pi. I mean, we could do the same thing with pi.
Yeah.
So would it be the same thing for pi?
I don't know. Because pi is not usually raised to a variable. If it was, I would assume so. But, well, actually, we would know. Because we had the one in there, the derivative of a to the x, which would be like pi to the x. Which is a to the x ln of a. Or a to the u ln of a. All right, so this is we've got a double product rule going on here.
Yeah.
So, y prime would equal derivative of the first, so 2x e to the x plus x squared, derivative of the second, e to the x. So when it's just e to the x, the derivative is just e to the x. So that's nice and easy. That's why when you do these ones with a product rule where it's just like e to the x, you've got to be really intentional to be like, okay, I took the derivative of the first times the second plus the first times the derivative of the second to make sure you're paying attention, because it can get confusing of which one did I do it for? Minus, I would bracket this off just because it's another product rule and there's a minus sign there. Derivative of the first is just 1, so e to the x plus x e to the x. Now I would go through and change all the signs here. So this would be 2x e to the x plus x squared e to the x minus e to the x minus x e to the x. Now, would you agree that these two are like terms?
Yes.
So I'm going to combine those. So I'm going to end up with x squared e to the x plus x e to the x minus e to the x. Now, I did it in this order because I tried to keep my x terms in descending order like I normally would. There's no rule about that with these. That's just a personal preference. You could if you were so inclined, factor out the e to the x. The book does not. You do not have to. But there is an e to the x and everything, so you could if you wanted to. Any questions on that one? That was a little more chaotic. But you see what I mean? Like, even the product rules of these are not nearly as bad as some of them are.
I'm not gonna lie, I probably would have factored out the e to the x.
Huh?
I probably would have factored out the e to the x.
I was going to, and then I looked down and saw the book didn't, so I just left it. All right, 10. Y equals e to the x squared. And they actually have the x squared in parentheses here. All right, so
Is there any particular reason why they would have the x squared in parentheses?
I assume it's just to know that e is being raised to that whole thing.
Instead of like e to the x.
Squared. Yeah, it's like e to the x squared. So the derivative, we copy this exactly down. So e to the x squared. And I will always just leave a space instead of going back and rewriting it because I know I'm just taking the derivative. And then I need the derivative of x squared, which is what? 2x. So 2x e to the x squared. Now, if you wrote it like this, I will know what that means. But if you want to keep it in parentheses, since that's what they did, you can.
On the AP exam, we should probably put it in.
I would say if they started out in parentheses, I would leave it, yes, on the AP exam. But as far as, like, in here, like, if I put this problem on a test, I probably would not put the parentheses on it because I don't think it's that confusing. I think they just do it for notation, so you see what e is being raised to. Let's see. 12. Y equals 9 to the negative x. So this is like the a to the x one. So the derivative of that is, where is it? A to the x ln of a. So we would copy this down exactly. So 9 to the negative x times the ln of 9. However, that's if it's just raised to x. We still have the chain rule. So the derivative of negative x is negative 1. So I need to put a negative out here to get that one. I'm going to do one more, the bell may ring, but it's really short, I promise. It's like 2 lines. But if we finish that, we'll only have 5 left to do tomorrow. So, y equals 3 raised to the cotangent of x. So this is the same thing as the one we just did. I now just have a chain rule where a trig function's involved. So, y prime is going to be 3 raised to the cotangent of x, always times the ln of whatever the number of the base is, so ln of 3. Now, what is the derivative of cotangent? Yep, negative cosecant squared of x. So the only thing that I would really do differently as far as rewriting this to wrap up the whole problem is if I was going to leave it, I would move the negative to the front and say negative 3 to the cotangent of x, ln of 3 cosecant squared of x, and probably put parentheses around cosecant squared of x, if I'm being honest. Oh, thank you. So that's really the only thing different that I would do. Do y'all want any problems to this point or no?
Yeah.
Just do them tomorrow. We only have 5 left. They're about the same length, honestly, as these, so it probably won't take us more than about 15 to 20 minutes to do them. So y'all can decide tomorrow if you do want to go ahead and take the physics test, or physics test during 5th and then do calculus last, or go ahead and get calculus done, and you can use time. I don't care how you want to do it.
I'd rather do physics first.
So get that out of the way.
Yeah.
I feel like physics probably won't take you the whole time either, just because I feel like this is an easier unit, so